Let's increase our discussion to a notch higher and discuss questions in section B. Is that okay? Now that we have to discuss questions in section B, these questions constitute from 9 to 14, okay? These are the questions which are there in section B. Let's see what happens the case with question number 9. Take a look at it, read it, and then try and understand what are the concepts which the question is demanding to be used. The question is saying there is a bag which contains 12 green balls and some red balls. So this bag is containing 12 green balls and there are some red balls which also this bag is containing. That's it. There is a bag which either contains red ball or green ball. There are in total how many balls inside the bag? So, total number of green balls in the bag is 12, and also there are some red balls in the bag. So, suppose the total number of red balls in the bag is X. That means overall total number of balls in the bag is 12 plus X, isn't it? There are 12 green balls in the bag and some red balls in the bag, that's it. Suppose those some red balls in the bag are X red balls. So overall total number of balls in the bag become 12 plus X. 12 green balls plus X red balls. Let's read further. Now it's a bag consisting of 12 green balls and some red balls. So overall there are 12 plus X balls in the bag. What I do is I put my hand inside the bag and draw a ball. The question is asking me the number of red balls in the bag. That means I have to find out what is the value of this X. Now two types of probabilities can be here. When I am putting my hand in the bag to draw a ball, either that ball can be green or that ball can be red. Suppose I say that A is event of drawing a red ball. And I say B is the event of drawing a green ball. Okay? So A is the event of drawing a red ball, B is the event of drawing a green ball. Because when you are putting your hand in the bag, either you are going to draw a red ball or you are going to draw a green ball, either of the two. Now, if these are the two events which govern the drawing of a ball, that means there can be two types of probabilities. Either the probability will be of drawing a red ball or there will be a probability of drawing a green ball. The question is saying the probability of drawing a red ball. So, probability of drawing a red ball means probability of event A is half. It is half of the probability of drawing the green ball. So, probability of event A is half of probability of event B. Because there can be only two cases, right? Inside the bag there are either green balls or red balls. So, when I am putting my hand to draw a ball, either a green ball will be drawn or a red ball will be drawn. That means two types of questions can be posed. Find the probability of green ball and find the probability of red ball being drawn. The question is saying, if the probability of drawing a red ball is equal to half of probability of drawing a green ball, then find out the number of red balls in the bag. So, what is the probability of drawing a red ball? Probability of drawing a red ball. So, among 12 plus X number of total balls, X is the number of red balls. That means number of favorable outcomes is X and number of total outcomes is 12 plus X. So there are only x red balls out of 12 plus x total number of balls. So probability of drawing a red ball is x upon 12 plus x. Whereas what is probability of event B? Probability of drawing a green ball. Now out of 12 plus x total number of balls, there are 12 green balls. So 12 is the number of favorable outcomes and the total number of outcomes is 12 plus x. So 12 upon 12 plus x is the probability of event B. Now that I know the numeric values of probability of A and probability of B, let's use this relation to simplify this expression. Probability of event A, which is x upon 12 plus x, is half of probability of event B, which is 12 upon 12 plus x. Okay, so this can get cancelled. You get 6 upon 12 plus x. Now what you do, you can cross multiply, you get x into 12 plus x is equal to 6 into 12 plus x. Now obviously this x is number of red balls, right? Number of red balls can be what all? This can be either 0, there are no red balls, or 1 red ball, or 2 red ball, or 3 red balls, numbers like these only. That means all the non-negative integers ranging from 0 to infinity, 0, 1, 2, 3, 4 and so on. So this number can start from 0, go to 1, go to 2, go to 3. It will never be negative. It will never be negative. That means this bracket can never become 0, because this bracket can become 0 only when x is minus 12. When x is minus 12, that means I am trying to say there are minus 12 number of red balls in the bag. What do I mean? What is the meaning of minus 12 number of red balls? The number of red balls can start from 0, go to 1, go to 2, 3, 4 and so on. This can never be minus 12, and so this 12 plus x can never be 0, and that is why I can cancel this out from both sides, leading to give me x is equal to 6. That means by using the relation that probability of drawing a red ball is half of probability of drawing a green ball, I have found that inside the bag in total there are 12 green balls and 6 red balls, which gives me inside the bag there are 18 balls present. 12 are green and 6 are red. Very easy question, nothing difficult about the question. The direct formula of probability was used in order to deal with the question, and the relation which connects the probabilities of drawing a green and a red ball were already given in the question. You just had to use that relation and therefore come to the answer. Now that we have dealt with question number 9, a direct usage of the concept of probability, nothing great, nothing special, nothing difficult about it. Let's see what happens the case with the next question. Okay, so again a quadratic equation question. Just look at the importance of the quadratic equations chapter. Now that chapter is coming again and again in our question solving session in different ways. Okay, we have already encountered the concept of quadratic equations, the solution of quadratic equations or the roots of quadratic equations and the nature of roots of quadratic equations. Over here in some other way the same concept is being used, just the language is different. Now this is a quadratic equation, fine, ax square plus bx plus c with a certain a, certain b and a certain c. It is saying find the numerical difference of the roots of this equation. That means you are supposed to first find the roots of this equation. Okay. Now those roots can come out to be what all? Either if the discriminant of this quadratic equation is strictly greater than 0, both of them are going to come out to be unequal and real. If the discriminant is equal to 0, both of them are going to come out to be equal to each other. In that case, the difference of both of them will be 0. You have to find the difference of the two roots. So if discriminant turns out to be equal to 0, that means both the roots are equal to each other, and in that case, the difference between the two will be 0. And if the discriminant turns out to be negative, I will have two non-real roots. two distinct unequal non-real roots. So that is going to have some numerical difference, and even the first case where the discriminant is strictly positive, even in that case I will be having two unequal real roots, so there will be some numerical difference between the roots. But if the discriminant is equal to 0, the numerical difference between the roots will be 0 because both will be equal roots. Let's start finding the roots of this quadratic equation. I know that if my quadratic equation, I've already dealt with the concept. Let me just revise it. With this as the quadratic equation, the roots are given by the formula minus b plus minus under root b square minus 4ac upon 2a. Okay? That means over here I have x square minus 7x minus 9 equals 0. So if I just portray it in the format of my generalized quadratic equation, it is going to become 1 times x square plus minus 7 times x plus minus 9 equals 0. Where this 1 is my small a, minus 7 is playing the role of small b, and minus 9 plays the role of small c when compared to the generalized form of a quadratic equation. Now that I have this quadratic equation, I know what a, b, c are. These values of a, b, c are going to help me compute the roots of this quadratic equation. Now over here, x is equal to minus b. Minus b, that means minus of minus 7, which is 7, plus minus under the root b square, which means minus 7 square, which is 49, minus 4 into 1 into c, c is minus 9, whole upon 2 into a, 2 into 1, which is 2. What you get then? You get x is equals to 7 plus minus under root 49 plus 9 into 4 is 36 whole upon 2, which gives me x is equal to 7 plus minus root 85 upon 2. That means over here you're getting two unequal real roots. The first real root is 7 plus root 85 upon 2, and the next one is 7 minus root 85 upon 2, because the discriminant, which is this 85, inside the under root whatever is sitting is your discriminant. This 85 is your d, which is strictly greater than 0, and that is why you're getting two unequal real roots, and that is why there will be some numerical difference. It will not be 0. 0 numerical difference will only happen when both the roots are same, which is in the case when your discriminant is 0. So over here there will be some numerical difference. Let's take this as x1, let's take this as x2. So x1 minus x2. Numerical difference between the roots is this, which means what? 7 plus root 5 upon 2, root 85 upon 2, minus 7 by 2 plus root 85 upon 2. That's what is the case. This minus this is what you get. This gets cancelled. You get root 85 by 2 plus root 85 by 2, which delivers you with twice of root 85 by 2, which is root 85. And so the numerical difference between the roots is root 85. That is how easy this question was. Over here you just had to find the roots of this equation. Now that would have come out to be in 3 types. Either both are unequal and real, which is happening the case in this scenario. Either they would have been both of them equal, or they would have been again unequal but this time non-real. And so depending upon whatever the 2 roots of this quadratic equation are, by using the Sridharacharya formula, we found out the difference between both the roots. And that is what is the meaning of numerical difference between the 2 roots of a quadratic equation. Okay? Very easy question. Again, this is emphasizing on the importance of the chapter quadratic equations. So you cannot afford to ignore or take that chapter lightly. Let's see what happens to be the next question. 11th question is trying to say a horse is tied to a pole and that pole is fixed at the middle of the side of a square field. There is a side of a square field. So there is first of all a square field. A nice square field. So let this be your some kind of a square field. Now if this is your square field, the question is saying a horse is tied to a pole fixed at the middle of the side of a square field of edge 65 meters. So this edge in the square field, all 4 sides are of the same length. So this side is 64 meters, this is 64, this is 65, and that is also 65. So you have all the sides of the square of length 65 meters. It is saying that a horse is tied to a pole fixed at the middle of the side of the square field. So one of the sides of the square field is this, and there is a pole which is fixed right in the middle of this square field. That means I'll move exact same distance down and exact same distance up from both the sides, and this is suppose the pole. This pole is fixed right in the middle of a side of this square field. So one of the sides, you can take any sides, that side has right in the middle a pole fixed. And a horse is tied to that pole. Okay? There is a horse which is tied to that pole. Now, what is going to happen? This horse tied to the pole somewhere here. Okay? It's where it's tied. It's tied. Now, with a rope of 18 meters long. Now, what is this rope? This rope is 18 meters long. Here is your horse. Okay? Now, this rope is 18 meters long. Find the area of the field in which the horse can graze. Okay? Now, understand carefully. This is my horse. This is the rope which is tying my horse to the pole fixed at one of the sides of the square field. Okay? Now, understand carefully. This over here, this is my horse and it is tied to the pole. This horse can move and graze some area inside this square field. This is nothing but your square field. This completely is your square field. Okay? Now what happens is, if this entirely is 65 and suppose I say this is my midpoint, what is this much? This is what? 32.5? Right? And what is this much? This is again 32.5. But this rope is only 18 meters long. So maximum length of this rope is 18. The maximum far which the horse can go from this pole right now is 18 meters far. And if it keeps on moving 18 meters far, Isn't this the thing which is going to cover? What I'm trying to say is, if the length of the string is at its maximum, if the length of the rope is at its maximum, with that maximum length rope, the horse can move like this, like this, like this, and come over here when this point from here is 18. Right? Similarly, with the maximum length rope, the horse can move like this also when this part is again 18. Similarly, from here to here, anywhere, it's 18. Right? I am not saying the horse cannot come back, loosen up the little rope, and it can graze like this also. It can graze all over here. All of this the horse can graze. All this. It can just come back a little, it can loosen up the rope, and it can move into all this area. But what is the maximum? What is the maximum that the horse can do? It can, the length, the rope can be at its maximum, which is 18 meters, and with that maximum length rope, the horse can at the max move like this and cover like this. It cannot move beyond this, is what I am trying to say. It cannot move beyond this. The maximum it can go is here, which is from the point where it is tied to the pole, 18 meters above that, and from the point where it is tied to the pole, 18 meters below that. Even here also, from the point where it is tied to the pole, 18 meters ahead of that, 18 meters ahead of that, that is the maximum which it can go. And if it comes back a little, loosen up the rope a little, it can cover this entire area also. The question, because is saying find the area of the field in which the horse can graze. So as I told you, the horse can at the max be at these points. These. At the max, the horse can be at these points. Apart from it, it can just come back and graze all this area. It cannot move beyond it. Okay? The question is find this area. The area of the square field, the entire square field has a certain area. Out of that exact certain area, there is some area only over which the horse can graze, because the rope has a certain fixed length, 18 meters. So that rope, with the help of that rope, because it is tied to a pole, it cannot move infinitely ahead of it. It will have to stop after reaching the maximum 18 meters, and that is going to happen wherever it is moving, in whichever direction in the square field. It cannot move beyond 18 meters from the point where it is tied to the pole. Right? And so all in all, it can only graze in this much area, where from the point it is tied to the pole, maximum is 18, here it's 18, here it's 18, till here it's 18, till here it's 18. Because when it is here, that means when it is using the entire maximum length of the rope, that is the maximum point where it can reach. Apart from it, it can come back and graze in this entire area. And so what is the way to find the area which you can see over here? Right now we can see it, but can you give me the numerical value of the area over which the horse can graze? Well, again like we have dealt with the very first question, this in section number A, here this question is also reminding me of a certain concept of a circle. Can I not consider this particular part, this shaded portion, as suppose I have a circle with center O, okay, and the radius of this circle is, say, 18 meters. Now what I do is I draw like this. That means this entirely is my diameter of the circle, and I am interested in this sector of this circle. I am interested in this sector. Isn't this sector basically a sector with arc AB? this is a sector AOB. This is a sector, I should not write this point. This is a sector AOB in this circle with arc AB. Now, any sector is made up with an arc and an angle. So, the arc is AB which is making this sector, and the angle which it is subtending at the center of the circle is 180 degrees. This is a straight line, right? And so, this sector is nothing but a result of the arc AB subtending an angle of 180 degrees at the center. And this is the exact same scenario which is represented over here. If I wish to find this particular area among the entire area of square field, this is nothing but can be interpreted as the sector of a circle of radius 18 meters which is subtended by an arc AB which subtends an angle of 180 degrees at the center. And so, finding the area over here is same as finding the area of this sector. Understood? That is how we have to interpret the situational question in terms of mathematical format. So, if I have to find the area over which the horse can graze, which looks like this, that means in a circle of radius 18 centimeters, I have to find the radius, or I have to find the area of a sector which has arc AB subtending an angle of 180 degrees at the center. Because this completely resembles this. So, now I am going to use the formula of area of a sector. I know that area of a sector of angle theta. Now, every sector has an angle and has an arc which is subtending that angle. So, area of a sector of angle theta in a circle of radius r is what? What is the area of the sector? It is pi r square by 360 degrees into theta square units, because we are talking about area. And so, if you know the radius of the circle and if you know the angle which is subtended by the arc of the sector, you are able to find out the area of that sector. Right now, I am associating this entire situation with this sector. So, finding the area of the field over which the horse can graze is same as finding the area of this sector lying in the circle of radius 18 meters. So, I know the radius of the circle and I also know the angle theta which this sector has, of which area I am interested in finding. So, the sector of whose area I am interested in finding, I know the radius of the circle inside which that sector lies, and I also know the angle of that sector, so I can find the area of that sector. Thus, area of the sector AOB is pi r square. So, pi we are going to replace it by 22 by 7. This is pi r square, radius of the circle of which AOB is the sector. So, AOB is the sector of the circle of radius 18. So, pi r square multiplied by theta. Theta is the angle of the sector which is 180 degrees divided by 360 degrees. That's it. You just need to solve this and find out the answer. You are going to get not centimeters square but meters square, because every unit is given to you in meters. And so 509.14 approximately, you can check that, is coming out to be your area of this sector. But whatever is the area of this sector is same as the area of this particular portion of the square field, and this is that portion of the field over which the horse can graze, and so the area of the field over which the horse can graze is 509.14 meters square. Understood? That is how we have to deal with the question. Now this question basically did not directly ask you to use the concept of circle or sector, you know, it was not at all directly pointing out towards these concepts, but it was indirectly giving you the same concepts only in the question. But that is the very trick about the question. You have to interpret the question not just in the situational, the correct situational format, but also you have to interpret the situational format into mathematical terms. Only then you can connect it to some of the concepts of mathematics, use the correct formula and find the correct answer. Right? Easy enough, not at all difficult, just you have to know how to connect the question with the concept of which chapter. Okay, the next question is giving you and asking you for what values of p the equation this has coincident roots. I cannot believe this question again is stressing on the quadratic equations chapter. What is the meaning of coincident roots? Coincident roots is another name for equal roots. Okay? So it is saying what are the values of p which when you incorporate over here, this quadratic equation is going to deliver you with equal roots. I know that any quadratic equation has equal roots only and only when the discriminant of this quadratic equation, which is b square minus 4ac, that is 0. So if I want to, if I am given that this quadratic equation has equal roots, that means the discriminant of this quadratic equation is 0. That is the fact which is going to be used to give you the values of p. So let's do that. Here the quadratic equation is 1 plus p x square plus twice of 1 plus 2p into x plus 1 plus p. And the question is that this quadratic equation has equal roots. This quadratic equation has equal roots. That means its discriminant is 0. Now this thing is your A, this thing is your B, and this is your C when compared to the general form of quadratic equation. And so the discriminant is 0 means B square minus 4 into A into C is 0, right? The discriminant is 0 because this has equal roots. Coincident roots means equal roots. And now over here what happens, you just need to solve this for p. So start doing that. 2 square is 4 multiplied by 1 plus 2p whole square, 1 square plus 4p square plus 4p. Minus 4, 1 plus p into 1 plus p means 1 plus p whole square, which is 1 square plus p square plus 2p. Sort this out, this will be 4 plus 16p square plus 16p minus 4 minus 4p minus 8p. This will be 1 plus p square, plus 2p. So this will be minus 4 minus 4p square minus 8p equals 0. And so from here 4 gets cancelled. You have 16p square minus 4p square, which gives you 12p square. After that you have 16p minus 8p gives you 8p. And now you can take out what? 4p common. You get 3p plus 2 equals 0. You can take out 4p common, right? Because 4, 3, 12, 4, 2, 8. You can take out 4 common. You can also take out one p common because both have p's with them. And so this into this is 0. That means 4p is 0, 3p plus 2 is 0. Either this has to be 0 or this has to be 0, only then the product of them will be 0. Okay? 4p is 0 implies p is 0, or 3p plus 2 is 0, that means 3p is minus 2, or p is minus 2 by 3. That means if this quadratic equation has equal roots, it is only possible when p is either 0 or minus 2 by 3. Because if p is not 0 and it is not even minus 2 by 3, for any other p, the discriminant of this quadratic equation will not be 0, and therefore it will not have equal roots. It is going to have equal roots only and only when the discriminant is 0, which means only and only when p is 0 or p is minus 2 by 3. Apart from this, this quadratic equation will not be able to have equal roots. Now again, because the question was emphasizing on quadratic equations, I would again like to say that you have to spend good ample amount of time with that chapter. Understand that questions are very easy which are asked in the paper from that chapter. The only thing is that you should be clear with the concept, the formula of roots, what is the nature of roots, how does the discriminant decide the nature of the roots, all this. Let's see after this very easy question what happens to be the next question. Okay, so now there is AP coming into picture. Find the AP arithmetic progression if the sixth term of an AP. So sixth term of an AP is 19 and the 16th term is 15 more than the 11th term. These are all the facts given about this arithmetic progression. So what I am going to do right now, the question gives me the sixth term. It gives me that the sixth term is 19. It is giving me some information about the 16th term. It is saying that the 16th term is 15 more than the 11th term. But in order to form an AP, to generate an AP, I need the first term and the common difference. So let A be the first term of the AP and this D be the common difference. Okay? So if A is the first term, D is the common difference, then what is your AP? In that case, AP is A plus D, A plus 2D, A plus 3D, and so on. That is what your AP is. And nth term of this AP, the first term is A, second term is A plus D. In general, how does the nth term look like? Nth term of the AP is represented as AN, and this is equal to A plus N minus 1 into D. Once these things are understood, let's interpret the question. Sixth term of an AP is 19. So sixth term means A6. A6, which is by the formula A plus 6 minus 1D, that means A plus 5D. I don't know what is A and what is D, okay? So A plus 5D, this is given to be 19. Sixth term is 19. Then it is saying 16th term. So 16th term is A16, which is A16 is A plus 16 minus 1D. So A plus 15D. So the 16th term is 15 more than the 11th term. So this is 15 more than the 11th term. 16th term is 15 plus the 11th term, whatever that is. So this will be what? What is A11? A11 is A plus 11 minus 1D, A plus 10D. This is your second equation. So let's sort this out. You have A plus 15D is 15 plus A plus 10D. By equation 2, we have A plus 15D is equal to 15 plus A plus 10D. So what happens now? This A, this gets cancelled, after which you have 15D minus 10D is 15. What is 15D minus 10D? 5D is 15, which implies D is 15 upon 5, which is 3. That means out of the two unknowns which are required to write the AP, first unknown you have got A, or I should say D. D is something that you have got, which is 3. Once you have D, can you find out A? Yes, of course, I have equation 1 left. From 1, I know that A plus 5D is 19, which implies A plus 5 into 3 is 19, because D is 3. So A plus 15 is 19, or A is equal to 19 minus 15, which implies A is 4. That means the second unknown also is clear to you. That means by the two equations which we have made conceptually by understanding the conditions given in the question, these two equations have helped us find out the two unknowns which are used to find the AP, the A and the D. And once the A and the D is known, therefore, what will my AP be? AP therefore is equal to first term, then A plus D, 4 plus 3. Then A plus D, then you have A plus 2D. So A is 4, 2 times D means 6, 2 times 3 is 6, 6 plus 4 gives you 10, and so on. Your AP, desired AP is 4, 7, 10, and so on. That is how, by using the information or interpreting the information right in terms of mathematics, by using the knowledge about AP, we have found out the value of common difference and the first term, which is the only two things required to find the entire AP, and thus we have found the AP which is satisfying the condition that the sixth term is 19 and the 16th term. The 16th term is 15 more than the 11th term. That is how you deal with questions like these. Very simple, just the direct concept of AP is used, nothing more, nothing great. Let's see what happens to be the next question. Okay, so the last question of section B is dealing with what? It is saying find a point on the y-axis. So there is a certain y-axis and an x-axis. Any point on the y-axis looks like what? Any point which lies on the y-axis has x coordinate 0. So this looks like 0, y. Any point on the y-axis has x coordinate 0, so it looks like 0, y. This is your x-axis, this is your y-axis. Similarly, any point on the x-axis which is lying on the x-axis has y coordinate 0. So it looks like x, 0. That means whenever any point is lying on the y-axis or on the x-axis, out of the two coordinates which are required to write the point or represent a point, I already know one of the coordinates. It is 0. If the point is lying on the y-axis, the x coordinate is 0. And if the point is lying on the x-axis, the y coordinate is 0. That means the only left unknown happens to be one coordinate out of the two coordinates. Over here the question is saying there is a point lying on the y-axis, so that point looks like this. Suppose this is that point lying on the y-axis, 0, y is how it looks like. And that point is equidistant from these 2 points. Suppose this is my point B and this is my point C. Now this point is equidistant from -3, 2. So suppose this is your -3 and suppose this is your 2, just for example. So this is your point B, which is -3, 2, and you have 1, -2. So this is your 1 and somewhere here is your -2. So this is your 1, -2 or point C. This point on the y-axis is such that this distance from B to A is same as the distance from C to A. Why? Because this point is equidistant from these 2 points. So that point will definitely look like something like 0, y, and that point is equidistant from B and equidistant from C. That means in the question it's given that the distance between these 2 points. So distance between 0, y, which is your point A, and point B, which is -3, 2, is same as distance between 0, y, which is your point A, and your point C, which is 1, -2. I have to find what this point completely looks like, such that this is equidistant from B and C. Right now the arbitrary point that we have drawn on y-axis doesn't look like it is equidistant from B and C. That means definitely it is not going to lie somewhere here, it should lie somewhere below, right? But I don't know what exactly that point is. I will have to use my distance formula, correct? I will have to use my distance formula to calculate the distance between these 2 points and to calculate the distance between these 2 points and equate those 2 distances. What is the distance between, or I should say what is the formula of distance between 2 points x1, y1 and x2, y2? It is under root of x2 minus x1 whole square plus y2 minus y1 whole square. That's it. If you know the 2 points, you can very comfortably find out the distance between these 2 points. So right now, if my point A is 0, y and my point B is -3, 2, what is the distance between these 2 points? So let this be x1, let this be y1, let this be x2, let this be y2. Then the distance between A and B is under root of x2 minus x1. So -3 minus 0 whole square. That means -3 whole square, which is 9. So x2 minus x1 whole square plus y2 minus y1. So 2 minus y whole square. This is the distance between A and B. I don't know what y is, so I cannot completely find out the answer. This in a sorted out format becomes what? 9 plus 2 square is 4 plus y square minus 4y. A minus b whole square, a square plus b square minus 2ab. So this gives you 9 plus 4, which is 13. 13 plus y square minus 4y. Similarly, your point A is 0 comma y and your point C is 1 comma minus 2. Then in this case, what is the distance between these 2 points? So what you do, you take this as x1, y1, x2, y2. So the distance between A and C is under root x2 minus x1, 1 minus 0 whole square, which is 1, plus y2 minus y1, minus 2 minus y whole square. This is what is the distance between A and C. Let's solve this. Under root 1, 1 square is 1, plus minus 2 minus y whole square. So minus 2 whole square is 4 plus y square minus 2 into minus 2 into y, which gives you plus 4y. Right? Because here you have minus 2 into A into B. Correct? So this gives you 4y. Over here 1 plus 4 delivers you with a 5. And so this is what you get as the distance between A and C. Now I know that this point is equidistant, so these two distances are completely equal. That means I have under root what? Under root 13 plus y square minus 4y is equal to under root 5 plus y square plus 4y. Now what you do, you square both sides to remove the under root. And what you obtain then? 13 plus y square minus 4y is equal to 5 plus y square plus 4y. This gets cancelled. You get 13 minus 5, which is 8, minus y square minus 4y, which gives you minus 8y, which implies what? 8 is equal to 8y, or y is equal to 1. And so you have got that your y should be 1. That means the point which is equidistant from B and C is the point 0, 1. That is what is your required point. I told you it should be somewhere nearer. This is my correct point, which is 0, 1, which is equidistant from these 2 points. That's how interesting this question is. You were just given an arbitrary point on the y-axis. The moment you know the point is on the y-axis, that means you know one coordinate is 0. So half task is done. You don't need to find both the coordinates. You only need to find the left out coordinate, which is y. And that you have found out by using the fact that this point is equidistant from B and C. We just applied a distance formula, nothing great. We were just solving, applying this formula twice, equating both the distances, squaring both sides, and that has given me the unknown coordinate, the y coordinate, which is 1. And therefore the x coordinate I already had, the y coordinate is 1, so 0, 1 becomes my desired point. which is equidistant from B and C. Very interesting question, and that completes our section B. We have discussed section A and section B. The only advice I can give it to you is sit with them, practice them once more and understand the ideas which I have discussed while portraying to you the solutions of these questions. Okay? Whichever concepts were used in whichever question, I have discussed each and every concept, and that is how you have to attempt the questions in paper as well. The moment you see the question, try to recall the chapter of which that question is concerned to and the concept also which is required to deal with that question. And that is going to completely make you sail through the question. I'll see you in the next section, section C, and then we are going to combat the difficulty of section C and tackle each and every question very easily. So thank you. That's it for today. Study well and take care.